Imagine standing on a world that is trying to erase you. Above, Jupiter looms like a bruised electric god, a gas giant so massive it distorts the very horizon. Beneath your boots is a shell of ice harder than granite and colder than a grave. For decades, NASA posters sold us a beautiful, romantic vision. An ocean oasis with alien fish swimming in warm, dark seas. It is a vision that has fueled our imaginations for 30 years. It is also, based on the newest data from 2024, almost certainly a lie. The Europa we are only now beginning to understand is not an oasis. It is a high-radiation death trap, a world of jagged crystalline blades, toxic chemistry, and a catastrophic lack of the one ingredient life needs most. We are going to dismantle the myth of the perfect ocean world. We are going to look past the NASA posters and into the cold, radioactive reality of a moon that may be one of the most hostile environments in our solar system. From 100,000 miles away, Europa is a masterpiece of deception. It looks like a fresh coat of plaster, the smoothest solid object in the known universe. A flawless, white porcelain egg. But this smoothness isn't a sign of peace. It's the scar tissue of a world that is constantly erasing its own history. It lacks the jagged mountains of Earth or the deep, pock-marked craters of our moon. It looks like a billiard ball that has been dropped and cracked, its surface covered in long, reddish-brown streaks called lineae. For years, scientists looked at this smoothness and saw an invitation. They assumed the ice was a thin plastic skin, easily broken, allowing the warm water below to seep up and heal any wounds left by meteorites. This led to the thin ice model, the idea that the ocean was just a few kilometers down. For years, this was the central hope for future missions, a thin, fragile shell we could easily pierce. But as we'll see, new data is beginning to suggest that this shell is far more formidable than we ever imagined. A massive, frozen barrier that may be the first of many walls Europa has built against the possibility of life. But as we look closer, that invitation turns into a warning. If you were to attempt to land a probe on Europa's equator today, it wouldn't touch down on a smooth skating rink. It would be shredded before it even settled. Recent geological modeling suggests Europa is spiked with penitentes, 15-meter-tall blades of ice as jagged as obsidian. These form through sublimation, where the sun's weak rays turn ice directly into gas without melting it first. In the stagnant air of the equator, this process carves the surface into a forest of white daggers, a labyrinth of vertical spikes that make a landing almost physically impossible. The smooth moon is, at human scale, a fortress of glass shards. This is our first clue that Europa is not what it seems. The physical barrier is just the beginning. The real horror of Europa isn't the ice, it's the engine that keeps that ice moving. Europa is caught in a gravitational tug-of-war between Jupiter and its sister moons, Io and Ganymede. This creates tidal heating. As Europa orbits, it is stretched and squeezed like a ball of clay. This friction generates heat, enough heat to melt a global ocean that contains more than twice the water of all Earth's oceans combined. For 30 years, the presence of this water was enough to sustain our hope. We first confirmed its existence, not with a camera, but with a magnetometer on the Galileo spacecraft. As Galileo flew past, it detected a magnetic signature that shouldn't have been there, a secondary field induced by Jupiter's massive magnetism. The only thing that could create that specific electrical response was a global layer of salty, conductive liquid. Water equals life. That was the mantra. We imagined that this tidal churning would act like a giant pump, pulling oxygen from the surface down into the deep. On Earth, life as we know it, complex multicellular life, requires oxygen to fuel high-energy metabolisms. We assumed Europa's surface, which is constantly bombarded by Jupiter's radiation, was an oxygen factory. The radiation hits the water ice, splits the molecules, and leaves the oxygen behind. All Europa had to do was breathe that oxygen in through the cracks in its shell. But in March 2024, a study led by J.R. Saleh using data from the Juno mission shattered this assumption. By measuring the actual rate of hydrogen loss from the Moon's atmosphere, researchers were able to calculate exactly how much oxygen Europa produces. The results were catastrophic for the ocean oasis theory. Europa isn't an oxygen factory, it's an oxygen desert. The Moon produces between 12 and 18 kilograms of oxygen per second. That sounds like a lot until you realize that previous estimates were nearly 100 times higher. To put this in perspective, if you took all the oxygen Europa produces and pumped it into its massive ocean, there wouldn't be enough to sustain a single Earth-sized whale. The concentration is so low that the ocean is likely anoxic, devoid of the chemical fuel needed for anything more complex than a single-celled microbe. We went looking for an alien sea teeming with life. We found a global tomb of sterile saltwater. This data suggests that if Europa is to harbor anything at all, we have to look deeper than the chemistry of the water column. We have to play the devil's advocate and assume that life doesn't need oxygen to survive. On Earth, we have extremophiles, organisms that live in the pitch-black depths of the Mariana Trench, huddling around hydrothermal vents known as black smokers. These subterranean geysers spew out mineral-rich, superheated water from the Earth's mantle, creating a chemical soup that life can eat. If Europa has these vents on its seafloor, life could exist without oxygen, living off the internal heat of the Moon. This is the second pillar of the Europa myth, and it is also beginning to crumble. For hydrothermal vents to exist, you need a tectonically active seafloor. You need a core that is hot enough to crack the rock and circulate water through the crust. On Earth, this is driven by plate tectonics and a massive internal heat reservoir. On Europa, the heat comes from tidal flexing. But recent models of Europa's interior suggest a chilling reality. The seafloor may be dead. Because Europa is smaller than Earth, its internal pressure is lower. As the Moon cooled over billions of years, its silicate mantle likely became a solid, unbreakable shell. Without the intense heat of a molten core, the water in the ocean cannot penetrate deep enough into the rock to create the chemical reactions necessary for hydrothermal life. The seafloor of Europa isn't a bubbling cauldron of life. It is likely a cold, stagnant expanse of ancient rock, sealed off from the water by miles of sediment. The ocean is trapped in a sandwich, ice above, dead rock below, with no source of energy to kickstart the engine of biology. If there is no oxygen from above and no heat from below, what is left? This brings us back to that ghostly glow on the night side. This is known as radiation glow. It is one of the most haunting phenomena in the solar system. Jupiter's magnetosphere is 1,000,000 times stronger than Earth's. It traps electrons and ions, accelerating them to near-light speeds and slamming them into Europa's surface. This radiation is so intense that the surface receives a staggering 5.4 sieverts of radiation per day, a dose that would kill a human being in minutes. When these high-energy particles hit the ice, they excite the molecules, causing them to emit light. If the ice is salty, it glows green. If it contains magnesium, it glows blue. This glow is the sound of DNA being shredded. It is the visible manifestation of a radiation environment so hostile that even the most hardy Earth bacteria would be sterilized almost instantly. Scientists are now using this glow to map the chemistry of the ice, and what they are finding is not encouraging. The reddish streaks we see on the surface, the lineae, were once thought to be organic compounds or salts from the deep ocean. But new analysis suggests they may be something far more toxic: sulfuric acid. The radiation from Jupiter interacts with sulfur being spewed out by the nearby volcanic moon Io, raining down on Europa and turning its surface into a corrosive, acidic wasteland. If this material is being cycled back down into the ocean through subduction zones, the ocean itself may not be a pristine saltwater sea. It may be a global vat of dilute acid, a chemical environment that would dissolve the very building blocks of life. So, we have a moon with a surface of 15-meter ice spikes, a lethal radiation field that glows in the dark, an ocean starved of oxygen, a dead seafloor, and a chemical composition that leans toward the acidic. The ocean oasis is starting to look like a cosmic nightmare, but there is one final, even more haunting possibility. If life exists on Europa, it might not be in the ocean at all. And that is the most terrifying thought of all. For years, we have seen what look like plumes of water vapor erupting from Europa's southern pole, a mystery that began in earnest with the Hubble Space Telescope's 2012 discovery of hydrogen and oxygen geysers. We thought these were direct portals to the deep ocean. We imagined a probe flying through these plumes, catching alien microbes in a net and bringing them back to Earth. But recent high-resolution mapping and thermal data suggest a different origin. These plumes might not be coming from the ocean. They might be coming from brine pockets trapped within the ice shell itself. Think of Europa's ice crust not as a solid block, but as a sponge containing isolated brine pockets, shallow lakes trapped miles above the main ocean. These pockets represent a double isolation. They are cut off from the mineral-rich seafloor by the deep ocean and simultaneously starved of oxygen by the 29-kilometer ice ceiling above. They are shallow crustal bubbles, where any potential life is effectively entombed in a chemical vacuum. Some scientists point to chaos terrain, those strange jumbled regions on Europa's surface that look like a broken jigsaw puzzle, as evidence of these pockets. They believe these are places where the ice shell has collapsed, where warm diapirs of ice have risen from the depths and melted the surface from below. If these regions are active, they could be the lungs of the moon, the places where the oxygen-rich surface ice is dragged down into the depths. But if life evolved in the early days of Europa, when the moon was younger and warmer, it might have been trapped in these pockets as the moon froze over. If that's the case, any life on Europa is not part of a thriving global ecosystem. It is a collection of hermit civilizations, tiny clusters of microbes trapped in sterile, dark bubbles, forever isolated from one another. They are born, they evolve, and they die in a space no larger than a suburban swimming pool, never knowing that a global ocean exists just a few miles below them, and never knowing that a universe exists above the ice. This is a much darker version of the search for life. It's not a search for a new frontier. It's a search for a series of tiny failing lifeboats. These organisms would be the ultimate survivors, but they would also be the ultimate prisoners. They are cut off from the energy of the sun and the minerals of the core. They are slowly starving as the moon's internal heat fades. When we look at Europa through this lens, the mission of the upcoming Europa Clipper and the European Space Agency's JUICE mission takes on a new weight. We aren't just looking for life. We are performing a forensic audit of a dying world. We are looking for the habitability window, the brief period in a moon's history where the conditions for life overlap. On Earth, that window has been open for nearly 4 billion years. On Europa, that window might have slammed shut 1 billion years ago. The tragedy of Europa is that it looks so much like home. It has the water, it has the clouds, in the form of plumes, and it has the dynamic surface. But the deeper we look, the more we realize that water is not enough. Life is a delicate balance of energy gradients, the difference between hot and cold, the difference between acidic and basic, the difference between high-energy electrons and stable molecules. On Earth, those gradients are everywhere. On Europa, the ice shell acts as a giant insulator, a barrier that prevents those gradients from ever meeting. The oxygen stays on the top, the heat stays on the bottom, and the water in the middle is left in a state of chemical equilibrium. And in biology, equilibrium is another word for death. If life exists on Europa, it isn't a global civilization of alien whales. It is a desperate, localized struggle. It exists only in the cracks. It exists only in the moments between the radiation pulses and the freezing cycles. It is life on the edge of the impossible. When the Europa Clipper arrives in 2030, it will use ice-penetrating radar to finally settle the debate over the shell's structure. Recent 2025 data from Juno's microwave radiometer has already cast a shadow over the thin ice dream, suggesting the ice is a staggering 29 kilometers thick. Clipper will fly through the radiation belts, its electronics shielded by heavy layers of aluminum and titanium, to confirm if this massive frozen barrier is truly as impenetrable as the data suggests. It will look for the salts, the acids, and the elusive organic molecules that might signal a biological past. But we must be prepared for the answer to be no. We must be prepared for the possibility that Europa is a beautiful, glowing, radioactive desert. And in a way, that would be a more profound discovery than finding life. If a world with twice the water of Earth, with tidal heating and complex chemistry, is still sterile, it tells us something terrifying about the rarity of life. It tells us that follow the water is not a complete map. It tells us that the recipe for life requires more than just the right ingredients. It requires the right timing, the right energy, and a level of cosmic luck that we are only just beginning to appreciate. Europa sits there in the dark, orbiting the king of planets, a silent sentinel of ice. It glows with a light that would kill us. It hides an ocean that may be as empty as the vacuum of space. It is a world of contradictions, smooth but jagged, watery but dry, glowing but dark. We often look at the stars and wonder if we are alone. Europa may be the place that finally gives us the answer, and the answer might be a cold, echoing silence. As we move forward into the next decade of space exploration, we have to shed our romanticism. We have to stop looking for mirrors of Earth and start looking at the universe for what it actually is: a collection of extreme, hostile, and utterly alien environments. Europa is not our sister. It is an alien entity, governed by laws of physics and chemistry that don't care about our hopes for a second Genesis. Whether we find a thriving biosphere or a frozen graveyard, Europa will change us. It will force us to redefine what it means to be a living world. It will show us the limits of water and the power of radiation. And as we watch that ghostly green glow from our telescopes, we will realize that the most precious thing in the universe isn't water. It's the thin, fragile, and miraculous balance that allows life to not just exist, but to thrive. Europa is a warning. It is a mystery. And soon, it will be a destination. But when we finally arrive, we shouldn't expect a welcome. We should remember the words of Arthur C. Clarke. All these worlds are yours, except Europa. Attempt no landing there. We should expect a world that has been waiting in the dark for 4 billion years, perfectly content to remain a secret. The story of Europa is the story of our own maturing, the transition from the childhood of imagining life everywhere to the adulthood of realizing how hostile the dark truly is. The glow on the ice isn't a campfire, it's a warning light. Yet we go because the mystery of a dead world is as compelling as a living one. We go to know if the silence of the cosmos is the rule or the exception. The ice is waiting,